My name is Bo. I'm a postdoc fellow at McMaster University, and I'm going to present something more far away from us. So if you look at the night sky, they're teamed with stars. Some are close by, some are more distant across the galaxy. So in fact, a large number of them are sun-like stars. So it is pretty straightforward to ask, if there are other planets like our Earth, other planetary systems like our solar system. So indeed, the NASA Kepler mission, space mission, have discovered over 2,000 exoplanets over the past decades. So a few of them are actually Earth-like planets, which are possibly habitable. The big question is, how does this planet form? Are there many planetary systems in our galaxy like our own solar system? So to answer this question, we'll need to go back in time to see what the system looked like before the birth of these planets. So in the past few years, ALMA, the big telescope in Chile, actually discovered a bunch of nascent disks surrounding newborn stars. So these two systems here are a few hundred light years away from our solar system. So they look like rings and gaps in a flattened disk structure. So the astronomers are actually trying to understand whether there are already planetary objects present in the current stage of the structure. So in summary, actually, we have a good picture of how this formation process looked like for the planet's formation. So it all begins with a giant molecular cloud. So that is about a few hundred or 1,000 times the size of our solar system. And the cloud is so massive, it starts to collapse on its own gravity. So forming a flattened rotating disk structure with outflows. And planets start to form inside this structure. And finally, you give out a planetary system like our solar system. So however, this picture is not as simple as it seems. So the actual complication comes from the magnetic field. So even though the collapse will give you a flattened disk, the magnetic field permeating through the cloud actually will try to stop this kind of formation process, because the magnetic field are bended inward like this way here as the cloud collapses. The materials along the magnetic field lines are actually almost frozen into the magnetic fields. You can imagine that like a beads on a wire. So this means that the materials on the central disk part will be slowed down by the materials further away. So this is a very dangerous situation. That in some cases, the disk could be completely disappeared if this kind of mechanism is very efficient. So we call it the breaking. So the key here is actually how the neutral materials are actually coupled to the magnetic field, or how they tie to the magnetic field. We know that the ions and electrons, because they are charged, are easily tied to the magnetic field. So we can consider them to be frozen in, and they move along with the magnetic field. However, the majority of the cloud materials are made up with neutrals. So they're actually indirectly coupled to the magnetic field through the constantly colliding with the ions and electrons and charged dust grains. So our recent result actually shows that the nanometer size dust grains are the culprits that tie the neutrals to the magnetic field, because they're just bigger, but they're just big enough than the than the ions and electrons, and they can collide more often with the neutrals. So if the nanometer size dust grains are present, so it's very hard for the disk to form. But once you remove them, so the newborn stars will be likely to form a planetary system have a similar size to our solar system. So the other complication comes with the cosmic rays. There are strong ionization sources from the energetic events such as supernovae throughout our galaxy. So if you have a strong cosmic rays, are constantly bombarding the cloud. They're generating a lot of new ions and electrons. They will also try to make the disk smaller in size. So simply because there are more ions and electrons going around, so the magnetic field are more tight to the neutrals and the materials. So to summarize, the formation of the planetary systems are tightly related to the microphysics, such as the dust grain size, and also how strong the cosmic rays are look like throughout the molecular cloud. So if the small dust grains are too many, they'll kill the planet-forming disk very easily. And stronger cosmic rays will tend to make this smaller. But we're expecting to see actually a widespread of different sizes of exoplanet systems. So that is underway, and the astronomers are striving to see what we're gonna have in the future. Thank you.